This is Babitha, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. In this session, I am going to discuss problems related to the multistage amplifiers. So, in the problems of multistage amplifier, we are going to calculate the input impedance of the multistage amplifiers as well as the voltage gain, output admittance, as well as overall voltage gain and overall current gain as well as power gain of the multistage amplifiers. So in order to find the parameters of any amplifier circuit, first of all we have to go for the AC analysis of that particular transistor circuit. That particular circuit may be in any configuration. It may be the common emitter configuration, common collector or common base configurations. For any configured amplifier circuit, first of all we have to consider the as it is circuit, then we have to replace all the coupling capacitors as well as bypass capacitors by short circuit, and after that we have to replace all the DC sources with the ground, and next we have to indicate all the terminals of the transistor. Then after that we have to replace the transistor by its H parameter model, so that we can able to get the H parameter equivalent circuit of the amplifier for the different stages in the multistage amplifier. So from that circuit we can able to find the parameters of the amplifier here. So for example, I am taking the circuit, the common emitter circuit here with the voltage divider biasing. We are providing the supply voltage VCC and RC and the emitter resistance RE and the potential divider network R1, R2 used to provide the biasing for the circuit. And for this circuit, through the coupling capacitor or input capacitor, we are providing the voltage or input signal. And next, we are also having the emitter bypass capacitor CE here. And to measure or to take the output, we are taking the coupling capacitor or C out capacitor to measure the output voltage of this particular amplifier circuit. So this is the actual circuit diagram I am taking here, and for this circuit we have to short all the coupling capacitors as well as bypass capacitors. We have to short circuit here, and next we have to ground this DC source. Why? Because we are going for the AC analysis now. And after that we have to draw the hybrid equivalent circuit of this transistor here. So for that purpose, I am taking the three terminals of the transistor, that is base, collector and emitter terminal. Though it is the common emitter amplifier, so that's why emitter terminal I am taking common between the base and collectors here. So what are the elements which are connected to the base and emitter here in the hybrid model? So first element is the resistance which is connected, that is the input impedance of the CE amplifier, and next the voltage gain or reverse voltage gain multiplied with the output voltage VCE. This is connected between the base and emitter terminals, and also across the output side we will get the forward current gain HFE multiplied by the base current or input current of the transistor, and also we are having the HOE output admittance. So this is the hybrid equivalent circuit of this transistor, and along with this we are also having the remaining elements in the circuit. So along with this we are having for the base terminal R1, R2 resistances are also connected between base and emitter. So that R1, R2 resistances I am connecting here. And also we are having the source voltage Vs. And across the output side we are having the collector resistance here. And also in some cases we are also having the load resistance RL, and here we will measure the output voltage. and this one is grounded or acts like a common terminal between the base and collector. So this is the H parameter model or hybrid equivalent circuit of the common emitter amplifier. So this similar H parameter model is same for common base configuration as well as common collector configuration. The thing is these terminals will be changed here, and these notations will also change depends upon the which type of configuration we are utilizing here. And while calculating the transistor parameters or amplifier parameters, these are the formulas required here. These all formulas are in terms of H parameters here. That H parameters we need to calculate from this circuit. Okay, so this is the current gain formula, that is minus HFE by 1 plus HOE into RL, that is forward current gain by 1 plus output admittance into load resistance. And to calculate the input resistance, we can utilize either this formula or this formula, that is HIE plus HRE AA into RL. So if we substitute the AA value here, we will get this particular formula. So this is to find the input impedance of the transistor, and if you want to find the overall input impedance of the amplifier by considering the source resistance or also consideration, in that case that is the parallel combination of input resistance with the RB resistance, and again here RB is nothing but a parallel combination of both the potential divider network, these two resistances. And next, to find the voltage gain, we are taking current gain into load resistance by input resistance. And to find the output resistance, we need to utilize this formula. So along with that particular formulas, we also required here H parameters of 3 configurations of the transistor here. So the 4 H parameters, their corresponding values in the common emitter, common collector as well as common base configuration here. So to solve the problems in the case of multi-stage amplifiers, we need to remember H parameters for all the 3 configurations along with the formulas. And while analyzing the given circuit, whether we need to go for the approximate analysis or exact analysis here, we can able to analyze the circuit in 2 ways. So when we need to go for the approximate analysis and when we need to go for the exact analysis. So to check that particular condition, I am taking the output admittance of the transistor and also the load resistance of the transistor or output resistance of the transistor. So if we find this particular value, if this value is less than 0.1, then we need to go for the approximate analysis. And if this value is greater than 0.1, greater than or equal to 0.1, then we need to go for the exact analysis here. And why we are checking this particular condition for exact analysis and approximate analysis, we already discussed in the previous sessions. Okay, this is the condition to check for the exact or approximate analysis. So depending upon that, we have to utilize either formulas of approximate analysis or exact analysis. Whatever the formulas we have seen in the previous slide related to the exact analysis formulas. So while coming to the approximate analysis, we will neglect the HRE terms as well as HOE term in the formulas, so that the approximated formulas are: current gain approximated formula is minus HFE here, and input resistance is directly equal to the input resistance of the hybrid equivalent circuit, HIE, and the voltage gain equal to minus HFE into RL by HIE, and the total resistance or output resistance is the parallel combination of load resistance and output impedance of the circuit, that is always infinity here. So almost always we will get it as equal to the load resistance. So these all are the approximated formulas to calculate the amplifier parameters. And when we go for the approximate H parameter model, so these are the formulas for all the 3 configurations for approximate model. So in the previous slides we have seen for the exact analysis, these are the formulas for the exact analysis, and these formulas for the approximate analysis. Here we need to remember both the formulas in both the models. So while coming to the problems here, I am taking the multistage amplifier. In that multistage amplifier we are having two stages, and the two stages are, first stage is common emitter conversion and second stage is common collector conversion, that is shown in the figure. I am showing the figure first. The common emitter transistor, as well as we are having the common collector transistor. And for this, the RC resistance is connected. The value is 10 kilo ohms. RC1 we can call it as. And for this, we are also having the source resistance RS. Through this, we are applying the Vs voltage here, and this value is 1 kilo. And these two are applied with the common supply, that is plus VCC. And here we are also having RE2 resistance, value is 5 kilo ohms. So this one across emitter of second transistor, we are measuring the output voltage. Why? Because it is common collector. So collector terminal is common between the base and emitter, and across the emitter we are going to measure the output voltage here. So this is the circuit given in the problem itself, and along with that they also given the H parameters of the first stage, that is forward current gain is 50, input impedance is 2 kilo ohms, reverse voltage gain is 6 into 10 power minus 4, and the output admittance is 25 microamps per ohms. So these all are the parameters of common emitter configuration. And similarly, the second stage is the common collector configuration. Those H parameters are HFC, forward current gain in the common collector configuration is minus 51, and the input impedance is 2 kilo ohms, and the reverse voltage gain is minus 1, and the output admittance is 25 milliamps per ohms here. So for this circuit we have to calculate the input resistance, current gain, voltage gain, as well as the overall voltage gain and the overall current gain and output impedance of the circuit. These are the parameters we need to calculate from this multi-stage amplifier here. So the first step to find these parameters is, first of all, we have to draw the simplified or equivalent circuit of this given circuit. Then we have to check for whether we need to go for the approximate analysis or exact analysis. Depending upon that, we have to choose the formulas. Then we need to substitute the given values to find the asked parameters in the problem. So for that purpose, first of all, I am drawing the hybrid equivalent circuit of the common emitter, common collector configuration amplifier. So for that purpose, I am taking the first common emitter stage. Why? Because first stage is the common emitter stage, and for this source resistance is connected RS, and the voltage source Vs is also connected, and the output of this one is running the input of the second stage, and this is grounded here, and the collector terminal also grounded here. For the emitter terminal, we are connecting the RE2 resistance, and here we'll measure the output voltage V0. This is CC stage, and the input applied for this is V1, and the input applied for this is V2, and the output voltage is V0 here. And the input impedance of first stage, I am taking here it as RA1 or else RA dash here, overall input impedance of the first stage, and the output impedance we will measure across the output of the first transistor, that is across RC1. So this is the output impedance of the first stage. And similarly, the input impedance of the second stage, we are calculating here RE2 dash, and the output impedance across RE2. Output impedance of the second stage, here it is. So this is the emitter, base, collector of the first transistor, and this is the base, collector and emitter of the second transistor here. And only the input impedance we can indicate with R02 here. The overall input impedance we are indicating with R0. That is the overall two-stage output impedance is R0. First stage is R01 and second stage is R02 here. So this is the H parameter equivalent circuit. And next, to analyze the multi-stage amplifier, always we have to analyze the second stage first, then first stage. So for the analysis of the second stage, so in the analysis of the second stage, first of all, we have to calculate the value of HOE into output resistance. So here HOE into output resistance of the second stage is the RE2 here. Why? Because in this circuit, the resistance RE2 is there here. So HOE value is 25 into 10 power minus 6, and the RE2 resistance value is 5 kilo ohms. So if we calculate this value, we will get it as 125. So this value is greater than 0.1 here. So HOE into RE2 value is greater than 0.1. So that we have to go for the exact analysis here. There is nothing but we have to utilize the exact analysis formulas to find the amplifier parameters. So the first parameter I am going to calculate here, it is current gain of the second stage. So I am indicating with AI2 here. So the current gain is the output current by input current. The output current of the second stage is IE2 here, and the input current of the second stage is IB2 here. So in terms of H parameters, if you write, this formula is HFE by 1 plus, second stage is common collector stage. So it is minus HFC by 1 plus HOC into RE2 resistance. So HFC value is minus 51 divided by 1 plus HOC value is 25 into 10 power minus 3, and RE2 resistance value is 5 kilo ohms. So if we simplify it, we will get it as 45.3 here. This is the current gain of the second stage. And next, input resistance of the second stage, that is the second parameter, input resistance of the second stage, that is RI2. So the formula for this is HIC plus HRC into current gain of second stage into RE2 again. So HIC value given it as 2 ohms, and HRC value is 1 here into current gain just now we have calculated, that is 45.3 into RE2 resistance is 5 kilo ohms. So if we simplify it, we will get it as 228.5 kilo ohms. This is the input impedance of the second stage. And the next parameter we need to calculate here, it is voltage gain of the second stage, that is AV2 here. So this AV2 we can calculate by multiplying the current gain of the second stage into load resistance, that is RE2 here, and the input resistance is RI2 here. So in this case, AI2 is 45.3 and the RE2 resistance is 5 kilo ohms and RA2 is 228.5 kilo ohms. So if we simplify it, we will get it as 0.991 as the voltage gain of the second stage, that is common collector stage. So from the second stage, we have calculated all the amplifier parameters. Similarly, we need to calculate the parameters for the first stage. For that purpose, we have to go for the analysis of first stage. So in that case, again we need to check the value of HOE into RL1 here. HOE into RL1 I am taking. So RL1 is the load resistance of the first stage or output resistance of the first stage. So here always the output resistance of the first stage acts like an input resistance of the second stage. So to calculate this value, RL1 value, we have to take the parallel combination of the output resistance of the first stage, that is RC1, parallel with the input resistance of the second stage, that is RI2 here. So if we substitute RC1 and RI2 values here, RC1 is 10 kilo ohms and it is 228.5 kilo ohms. And next 10 plus 228.5 kilo ohms. So if we simplify it, we will get it as 9.58 kilo ohms, the RL1 value. So if we substitute this value, HOE is given it as 25 into 10 power minus 6 and this value is 9.58 into 10 power 3. So if we simplify it, we will get it as 0.239. So this value is also greater than 0.1 here. So again, we need to go for the exact analysis for the first stage also. Okay. So again, to find the current gain of first stage, that is AI1 here. AI1 equal to the output current of the first stage is collector current and the input current of the first stage is base current. So it is minus HFE by 1 plus HOE into RL1 here. First stage is common emitter configuration, so that's why in terms of subscript E we are writing the formulas here. So here minus HFE value is given as 50 and HOE value is 25 into 10 power minus 6 and RL1 just now we have calculated 9.58 kilo ohms to 10 power 3. So after simplification it is minus 40.34 is the current gain of the first stage. And next we need to calculate the input resistance of the first stage. Input resistance RA1. The input resistance RA1 is HIE plus HRE AI1 into RL1 here. So HIE value is given it as 2 kilo ohms and HRE is 6 into 10 power minus 4 and AI1 is minus 40.34 into RL1 is 9.58 into 10 power 3. So after simplification, we will get this value as 1.768 kilo ohms. So this is the input resistance of the first stage. And next parameter we need to calculate for the first stage is voltage gain. That is AV1 is equal to current gain of the first stage into output resistance of the first stage by input resistance of the first stage. So the current gain we got it as minus 40.34 and RL1 is 9.58 into 10 power 3 and the input impedance is 1.768 into 10 power 3 here. So after simplification it is minus 218.5 is the voltage gain of the first stage. So we have calculated all the parameters for the first stage as well as the second stage. Then we need to calculate the output resistance for the two stages. So for that I am taking the output resistance R0. So to find the output resistance R0 we cannot calculate directly. Why? Because in the H parameters we are having the admittance here. So first of all we need to calculate the output admittance, then we have to take the inverse of that when we'll get the output resistance. So the output admittance, we can calculate here it as Y0 of first stage. I'm writing here it as HOE minus HFE into HRE by input impedance plus source resistance. So this is the formula for the output admittance. So if we substitute the values, we will get it as 25 into 10 power minus 6 is the HOE value, and HFE value is 50, and HRE value is 6 into 10 power minus 4, and HIE value is 2 kilo ohms, and the source resistance value is 1 kilo ohm here. So after simplification, it is 1.5 into 10 power minus 6 amps per volts. This is the Y01 value. So next, to find the output impedance of the first stage, we have to take 1 by admittance. That is 1 by 1.5 into 10 power minus 6. That value is 66.7 kilo ohms. So the output impedance of the first stage is 66.7 kilo ohms here. And next, again, the output impedance of the first stage by considering the collector resistance into account. So in that case, the value is R01 equal to R01 dash is equal to R01 into RC1 by R01 plus RC1, the parallel combination of two resistances. So that is 10 into 66.7 divided by 10 plus 66.7. Both are in kilo ohms, so that we will get it as 8.69 kilo ohms is the overall output impedance of the first stage here. And next, this R01 dash acts like a input resistance or source resistance of the second stage. Input resistance of second stage it is. So from this, we can calculate the admittance of the second stage, that is HOC minus HFC into HRC by HIC plus RS2 dash here. So here we have all the values. These are the common collector H parameter values we need to substitute here. That is 25 into 10 power minus 6 HOC value is, and HFC value is minus 51, and HRC value is 1. HIC given it as 2 kilo ohms, and RS2 value is 8.69 into 10 power 3. So this value is 4.79 milliamps per ohms. And from this, we can find the output impedance of the second stage, 1 by admittance, that is 1 by 4.79 into 10 power minus 3. So if we simplify, we will get it as 208 ohms. This is the output impedance of the second stage here. And next, the output impedance of the amplifier, overall amplifier, if we take, in that case, we will get it as R02 parallel with RE2. Why? Because in the second stage, we are also having the emitter resistance RE2. So the overall resistance are not equal to this much, that is R02 into RE2 by R02 plus RE2 here. So if we substitute the values, we will get it as 199.67 ohms as the overall output impedance here. And next, we need to calculate overall current gain, that is the multiplication of current gain of the first stage as well as current gain of the second stage. So overall current gain, I am taking here it as AI, that is equal to minus IE2 by IB1 here. This is the output current of the second stage. This is the input current of the first stage. So this one we can write it as minus IE2 by IB2, and again IB2 by IC1, the output of the first stage, and again IC1 by IB1 here. So here this particular term is the current gain of the second stage, and this is the current gain of the first stage, So we need to calculate this particular value IB2 by IC1. Then we can able to find the overall current gain here. So to find IB2 by IC1 value, I am taking the resistances which are present in the input of the second stage and the output of the first stage, RA to RC1. So here it is the collector terminal of the first stage. Okay, and here the collector current of the first stage is flowing, and here the input resistance or input current of the second stage is flowing here. It is IC, so IB2 here, base current IB2. So from this we can write the ratio. The value it is the opposite resistance is RC1 for this divided by total resistance RC1 plus RA2. Okay. So if we substitute the values, RC1 is given as 10 kilo ohms and 10 kilo ohms plus RA2 228.5 kilo ohms. So it is minus 0.0419 is IB2 by IC1 value here. So now to find the overall current gain, AI, I am substituting all the values AI2 into AI1 into IB2 by IC1 values. So here AI2 value is minus 45.3 and AI1 value is minus 40.34 and this value is minus 0.0419. So after simplification it is minus 76.56. This is the overall current gain of two-stage or multi-stage amplifier. And next we need to find the overall voltage gain. So overall voltage gain is again the multiplication of gains of two individual stages here. So I am writing here it as V0 by V1, that we can write it as V0 by V2 into V2 by V1. So this is the gain of the second stage and this is the gain of the first stage here. So these two values we have already calculated. So the second stage gain is 0.991 and the first stage gain is minus 218.5 here. So overall it is minus 216.5 is the voltage gain or overall voltage gain of the two-stage amplifier here. So in this way, for the given multi-stage amplifier, we have to find all the parameters. And second problem is a CE/CC amplifier. Again it is having the source resistance 1 kilo ohm and the collector and emitter resistances 4 kilo ohms. So the H parameters of the first stage are these and these are the H parameters of the second stage, and we have to find all the current gain, voltage gain as well as input impedance. So here we need to draw the CE/CC amplifier with the given resistance and source resistance values here. So for that purpose, I am drawing the common emitter transistor. I am taking first and source resistance Rs and the source voltage Vs, and the collector resistance RC1 is 4 kilo ohms and this is connected to the second stage. This is applied to the common supply. This is CE stage. This is CC stage. Okay, and the emitter resistance RV2 is also 4 kilo ohms. So it is grounded here. We here will measure the output voltage. So this is the circuit for the given parameters. So to solve the problem, first of all, we have to take the hybrid equivalent circuit, then check for the exact or approximate analysis, then substitute the values in the desired approximated formulas. So for that purpose, I am drawing the hybrid equivalent circuit with the source resistance Rs and the voltage Vs. This is CE stage and this is output of this is connected to the second stage. So this one is grounded and it is connected to the RE2 resistance 4 kilo ohms. These all are grounded here. Here we'll measure the output voltage. So this is the base terminal of the first one. This is the collector terminal of the first stage and the emitter terminal of the first stage. And in this case, this is the base terminal of the second stage. This is collector terminal, C2, E2, and this is the collector terminal C2 here. And here we'll apply the input voltage for first stage, here input voltage for the second stage, and this RE1 is the resistance for the first stage. And here, from here we will calculate the input resistance of the first stage, and from here we will calculate the input resistance of the second stage. And similarly, we'll calculate the output resistance of the first stage from here and the output resistance of the first stage from here. And the overall output resistance is R0 for both the stages. Here it is. So this is the H parameter model for the given circuit. And next we have to check for approximate as well as the exact analysis here. For that purpose I am taking HOE into RE2. Why? Because we are going for the second stage first. Always analysis we have to do the second stage first. So that's why HOE value is 25 into 10 power minus 6 and the RE2 value is 4 kilo ohms. So it is 0.1. So we have to go with the exact analysis. So while coming to the exact analysis, the current gain of the second stage AI2, I am taking here it as the output current of the second stage emitter current and the input current is base current. And the second stage is common collector. So that's why I am writing the formulas in common collector configuration, minus HFC by 1 plus HOC into RE2 here. So the HFC value is minus 51 and the HOC value is 25 into 10 power minus 6 and RE2 value is 4 kilo ohms. So we will get it as 46.36 is the current gain of the second stage. And next, input impedance of the second stage RA2, that is HIC plus HRC into AI2 into output resistance RE2. So HIC value here it is 1.2 ohms plus HRC value given it as 1 and AA2 is 46.36 and RE2 value is 4 kilo ohms. So if we simplify it, we will get it as 185.44 kilo ohms. That is the input impedance of the second stage. And next, the third parameter we need to calculate here it is voltage gain AV2, that is V0 by V2, and that is equal to current gain into output resistance by input resistance. So the values are 46.36 is the current gain, RE2 is 4 kilo ohms and RA2 is 185.44 kilo ohms. So this value we will get it as approximately 1 here. So the overall voltage gain of the second stage is 1 here. And similarly, we need to do the analysis for the first stage here. Again, to do the analysis, we need to check for the HOE into RL1 condition. So RL1 is the parallel combination of the output resistance of the first stage and input resistance of the second stage. So RL1 is equal to RC1 into RA2 by RC1 plus RA2. So after substituting the values, we will get it as 3.91 kilo ohms. So next, checking for HOE into RL1. HOE value is 25 into 10 power minus 6 and this one is 3.91 to 10 power 3. So this value we are getting here as 0.09. So it is less than 0.1 here. So we need to go for the approximate analysis. For the first stage, we need to go for the approximate analysis. So the first parameter of the first stage by using the approximate model, that is current gain of first stage, is directly it is the forward current gain of the H parameter model. So it is minus 50. And next, the input resistance of the first stage is directly equal to the input impedance of the H parameter model, that is 1.2 kilo ohms. And the voltage gain is the current gain into load resistance by input resistance. So we can also write it as minus HFE into RC by HIE in terms of H parameters. So if we substitute the values, HFE value is 50 and RC value is 3.91 into 10 power 3. HIE is 1.2 kilo ohms. So after simplification, we will get it as 162.91 is the voltage gain. So we have calculated the parameters of the first stage as well as the second stage, and next we need to calculate the total resistance RT. So that is the parallel combination of the load resistance of the overall circuit as well as the overall output impedance of the amplifier, that is infinity. So the value we will get it as RA and this value is 3.91 kilo ohms. So the total resistance is 3.91 kilo ohms. So these are the parameters for both the stage amplifier. And while coming to the third problem, this is CE amplifier. Both the stages are CE amplifier only. So that's why they are given the only one set of H parameters. These are similar for both the CE amplifier stages. And along with that, they given the source resistance, collector resistance and emitter resistance of the first stage, and also the collector emitter resistances of the second stage, and the potential divider values of the first stage as well as second stage are given. So all the values of the two-stage amplifier is given. Then we need to find the current gain, voltage gain, input output impedances here. So before going to find all these values, we have to draw the small signal equivalent circuit by using the given values. So both are CE amplifiers, CE stage. So that's why I'm taking the first H parameter model, HIE. This is HIE1, HRE1, VCE1, and this is HFE1 into IB1. This is HOE. So this is the hybrid equivalent circuit for the first stage. And we are also having the collector resistance RC1 of the first stage. And along with this, we are having the source resistance and source voltage RS, VS. And similarly, for the second stage also, we are having, this is collector of the first stage, and from here second stage is starting. So this is the hybrid equivalent circuit of the second stage, HIE2, HRE2, VCE2, HFE2 into IB2, HOE2 here. So we are having the collector resistance RC2 here, and here we'll measure the output voltage. So this is the collector of the second stage, and this is the emitter of the first stage. This is the emitter of the second stage, and base 1, this is base 2 here. and here we are applying the V1 voltage, and here we are applying the V2 voltage for both the stages. So this is the H parameter equivalent circuit for the CECE amplifier for the first stage as well as for the second stage. So from this circuit, we need to calculate the parameters of the both the stages of CE amplifier. So again, I am taking the second stage first. Okay, that is CE amplifier. Again, we need to check HOE into RL resistance value. That is 25 into 10 power minus 6, and the load resistance is 4 kilo ohms. So this value is 0.1. So we need to go for the approximate analysis. So in the approximate case, if we go for the current gain of the second stage, that is minus HFE directly. So that value is minus 50. And input impedance RI2 is directly the input impedance of the second stage, that is 1.2 kilo ohms. And the voltage gain of the second stage is current gain into load resistance by input resistance RI2, that is minus 50 into 4 kilo ohms divided by 1.2 kilo ohms. So it is minus 166.67. This is the voltage gain of the second stage. And similarly, we need to find the first stage parameters. Again, for that, we need to check for the HOE into RL dash value. So to find RL dash, we have to consider all the input resistances in the hybrid equivalent circuit. We are having the collector resistance RC1, that one parallel with the potential divider network R1, R2, and that is parallel with the input resistance. So if we substitute all these values, we will get it as 881.8 ohms as the RL dash. So now check for the HOE into RL dash, that is 1 by 40 into 10 power minus 3 into 881.8 ohms. So this is 0.022, which value is less than 0.1. So that we need to go for the approximate analysis again. So if we do the approximate analysis for the first stage, so the first parameter is the current gain, AI1, that is equal to minus HFE, that is minus 50 only. And the second parameter is RA1, that is equal to HIE, that value is 1.2 kilo ohms. And the third parameter is voltage gain, that is current gain into load resistance by input resistance here. So that values are minus 50, load resistance is 881.8 ohms, and the input impedance is 1.2 into 10 power 3. So this is minus 36.74 is the voltage gain of the first stage. So to find the overall voltage gain here, so the overall voltage gain AV is the voltage gain of the first stage multiplied by the voltage gain of the second stage. That is minus 166.67 into minus 36.74. It is 6123.45 is the overall voltage gain. If we compare with the single stage, in the case of multi-stage, gain value is improving very high here. Well, coming to the next problem. This is the Darlington emitter follower circuit. It is different to the previous problems. In that previous problems, we have seen CE-CC configuration as well as CE-CE configuration. But it is different from the two states of amplifiers here. So this Darlington emitter follower using two similar transistors with parameters, with H parameters. These are given. And along with that amplifier parameters, source resistance and voltage divider parameters also given. From this, we need to find the current gain, voltage gain, input output impedances. So from these given values, I am drawing the Darlington amplifier circuit with the voltage divider biasing. So always for the transistor voltage dividing means we are having two resistances R1, R2 connected to base of that transistor, and the output of this one is connected to the input of the second stage here. And here we are having the emitter resistance, and it is connected to plus VCC, and through the source resistance we are applying the source RS resistance is connected, that is 400 ohms. 400 ohms is given, and the output voltage we are measuring here across the second stage. So here R1 value is 90 kilo ohms, R2 value is 10 kilo ohms given in the problem itself. This is the first stage, this is the second stage, this is the Darlington amplifier. So to calculate the amplifier parameters, I'm drawing the equivalent circuit of this one, that is with the two transistors. And input of this one is connected to only source resistance RS. Here it is PS. We are having the emitter resistance and two potential divider resistances, and we are measuring the output voltage here. So emitter resistance is 3 kilo ohms, and it is 90 kilo ohms and 10 kilo ohms plus VCC, Q1 and Q2 transistors here. And this is grounded by, because we are taking the AC analysis here. So again, go with the analysis of the second stage here. So to find that, again I need to calculate the load resistance of the second stage to check HOE into RL2 value. So that is the parallel combination of all these three resistances, that is 3 kilo ohms parallel with 90 kilo ohms parallel with 10 kilo ohms. So we will get it as 2.25 kilo ohms, the RL2 resistances. So from this you can calculate HOE into RL2 condition. This HOE is 20 into 10 power minus 6, and this value is 2.25 into 10 power 3 RL2 value is. So this value is 0.045, which is also less than 0.1. So we need to go for the approximate analysis. So in the approximate analysis, first we need to calculate the current gain of the second stage. Okay, it is approximate of the common emitter configuration, so the formulas are different. It is 1 plus HFE. In the previous case, it is directly HFE, but here it is 1 plus HFE here. That is 1 plus 50. The value is 51. And the second parameter is input resistance RA2, that is HIE plus 1 plus HFE into RL2 resistance. So HIE value is 1.1 into 10 power 3, and 1 plus HFE value is 51, and the RL2 value is 2.25 into 10 power 3. So we will get it as 115.85 kilo ohms, the input resistance of the second stage. And next, the voltage gain of the second stage, that is 1 minus HIE divided by input resistance of the second stage, that is 1 minus 1.1 into 10 power 3 by RA2 value is 115.85 into 10 power 3. So it is 0.99. The second stage gain is 0.99. So these are all of the values of second stage, and similarly we need to go for the first stage analysis. Again we need to check HOE into RL1 value here. So in this case, RL1 is the input impedance of the second stage, that is we have already calculated 115.85 kilo ohms. So this value 20 into 10 power minus 6 into 115.85 into 10 power 3. So it is 2.317. It is greater than 0.1. So in this case, we have to go for the exact analysis of the amplifier of first stage. So in the case of exact analysis, the current gain is 1 plus HFE by HOE into RL1. So if we substitute the values, we will get it as 22.011. And the second parameter is input impedance. So that is HIE plus current gain into RL1. If we substitute the values, we will get it as 2551.1 kilo ohms. And the voltage gain of the first stage is 1 minus HIE by RL1. After substituting the values, we will get it as 0.999. So this is the input impedance of the first stage. So these all are the parameters of the first stage here. And next we need to calculate the overall voltage gain AV here. That is the multiplication of the gain of the first stage as well as second stage gains here. That is 0.999 into 0.9. We will get it as 0.989 is the overall voltage gain. It is merely 1 here. And next, overall input resistance RA. To calculate this, that is equal to RA1. And next, to calculate the overall voltage gain AVS by considering the source resistance into consideration, that is V0 by Vs here. So I can write it as V0 by Vi into Vi by Vs. So here V0 by Vi is the voltage gain, and Vi by Vs from the input circuit we can calculate, that is source resistance and the R1 resistance we are having. So here Vi by Vs, if you write, we will get it as Ra by Ra plus Rs from this circuit. So this value I am writing it here it as Ra plus Rs. So after substituting all these values and after simplification, we will get it as 0.988. This is the overall voltage gain. And next, output impedance. So the output impedance of the first stage is R01. The formula is source resistance plus input impedance by 1 plus HFE. So after substituting all these values, we will get it as 29.41 ohms. And similarly for the second stage, it is R01 plus HIE by 1 plus HFE. So after substituting all these values, it is 22.14 ohms. So this is the first stage and second stage impedances, but the overall multi-stage amplifier output impedance is the parallel combination of this resistance R02 and the load resistance RL2. If we substitute these two values, we will get it as 29.92 ohms is the overall output impedance of the given Darlington amplifier. So in this session now we have discussed the problems related to multi-stage amplifier. In that we have discussed CE amplifier as well as CC amplifiers and Darlington amplifier related problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.